Hello. Yes. We welcome you back to PSSB, Physical Sciences Silver Bullet with me, Richard here. Yes, today we are looking at this question. It says that consider the two setups below. So we have setup A and B. Okay. Let us see what we have in A. What we have in A, we have the thermometer and an aluminium strip immersed in copper sulfate solution. Also, what do we have in B? We have the copper strip immersed in aluminium sulfate solution, and we have our thermometer placed. Okay? And the question says, identify which of the setups above is feasible or spontaneous. Explain your answer. So which of the two is feasible? Okay, to be feasible, it means that it can proceed without any energy input. Okay. This part, we are going to expound on it as we proceed. But the answer is A. Let us look at what we have in A and what we have in B. Okay. In A, we are having aluminium solid reacting with copper sulfate. Okay. So in other words, we are having aluminium solid combining with copper to ions, because sulfates are spectators. This is the reaction we are observing. Okay, in B, what do we have? We have the copper strip. So we have the copper solid reacting with aluminium sulfate. Okay, technically, this is the reaction taking place. It's copper solid reacting with aluminium ions. So, yes, we have these two reactions. And the question is, which one is feasible? So to answer this question, we use the table of standard electrode potentials. And to me, the most preferred table is 4B. Table 4B, the elements which start which is at the top are strong reducing agent. And the elements at the bottom are weak reducing agent. So when you look at, we are looking at two elements in compulsion. And the question is, which one comes first? So the element which comes first is aluminium. Copper comes later. So the element at the top is a stronger reducing agent. So it reduces this one and this one. So in other words, in reducing this one, aluminium undergoes oxidation, and this one becomes reduced. So the question is, which one? For that one to occur, the first one must be a solid and the next one must be ions. And which of the two is typical of what we have here? It is this one. It is this one where aluminium, the first one is the solid and the next one is the ion. So, which means that this one is feasible. It's spontaneous. It can occur without energy input, while this one cannot. If you want this one to occur, you need to put in energy. You have to connect a battery. So the answer is answered. Which one is spontaneous? A. Reason, it is energetically favorable. In which way? Aluminium is a stronger reducing agent compared to copper, implying that aluminium reduces copper to copper solid and aluminium undergoes oxidation. Yeah, then we come to this question. It says, state the observable change in temperature in setup A. Okay, we know A is spontaneous, it's feasible, it's taking place. So if it takes place, what do we observe on the thermometer? There is temperature increase. There is a rise in thermometer. Yeah, then we come to setup B. What is observed in setup B? There is no temperature change. So the thermometer reading remains unchanged. Yeah, that is it. Reason being that this one is not spontaneous. So there is no reaction taking place here. Yeah, then we come to this question. It says, state the color change in setup A. Yeah, this is the setup we are talking about, which is feasible. Yes, how do we observe the color change? How do we interpret it? Here you have to look at the equation which is taking place. So when you look at the scenario, what do you have? Like we said before, you have aluminium solid reacting with copper sulfate. This one gives you aluminium sulfate. That's the equation. Plus copper solid. Now, if you interpret this ionically, we are going to have aluminium solid plus copper 2 ions, giving you aluminium ions plus copper solid. Now, you need to be reminded that the sulfate ions are spectator ions, so we can ignore them in ionic equation. So with this equation, what do we notice? You have to know that because of the copper ions, this solution is blue. And it's now changing into copper solid. Solid means it's not dissolved in water. So we are going to have brown solid suspended. So this is what you observe. We're having the blue being taken out. So what do you observe here? The observation is that the blue color of the copper sulfate solution fades or decreases in intensity. Yeah, that is it. Reason for fading is because the copper 2 ions, which are responsible for the blue color, are being reduced to copper solid. Yeah, then we come to this question. It says that state the color change in the setup B. Okay. Yeah, this is the B. And what do we said B is non-spontaneous. It's not feasible. So if this is not feasible, what's the color change? No color change. Yeah, then we come to this question. It says that write the reaction taking place in setup A. Okay. So what reaction are we observing in setup A? We said that it is aluminium solid, because the strip is aluminium, reacting with copper sulfate to giving you aluminium sulfate. Remember aluminium, the valence is 3, sulfate is 2. So you put a bracket here, plus copper. So this is what we are having. And this is the type of reaction taking place. Now, if the reaction required is ionic, what do? We cross out the spectating ion, we cross out the sulfate. And what do we have after that? We are going to have the aluminium solid plus copper 2 ions, giving us aluminium 3 plus copper solid. Yeah. That is that. Yeah, then we come to this question. It says that write the reaction taking place in setup B. Yeah, this is B we are talking about. And what did we not? We say that B is unspontaneous, it's not feasible. So if it's not visible, what does it mean? It means no reaction is taking place. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. Yeah, we urge you to subscribe, to comment, to like, to share. Yes, we believe we are simply the best. See you next time. Bye bye.